Welcome you all. In this session, we are going to discuss the assumptions in short circuit analysis. Outcome: after successful completion of this session, the student would able to analyze the short circuit analysis in power systems by assuming various functions. First, let us see the need for fault analysis. So the fault analysis is mainly done to determine the magnitude of fault current throughout the power system after fault occurrence. It is used to select the rating of fuses, circuit breakers, and switch gears. To check the MVA rating of existing circuit breakers when a new generator are added into the system. So the fault analysis is an important study in power system to determine bus voltages and current flowing in the lines during various types of fault. A fault is an abnormal condition in system. The fault occurrence in power system is mainly due to insulation failure of equipment, over voltage due to lightning and switching, natural causes like wind, storm accidents like birds shorting the lines, falling off tree along a line also cause over voltages. Due to non-linearity in elements, a sudden changes is attained in voltage. So these are the major causes of fault. The fault are classified into two types, that is a short circuit fault and open circuit fault. The short circuit fault are further divided into two. One is symmetrical fault and other one is asymmetrical fault. Symmetrical means balanced fault and other one is unsymmetrical is unbalanced fault. So short circuit analysis or short circuit study is one of the basic power system analysis problem. It is also known as fault analysis. When a fault occurs in power system, bus voltages reduces and a large current flows in the lines. This may cause damage the equipment. Hence, fault session should be isolated and the rest network is immediately to in order to save them from fault. This can be achieved by providing relays and circuit breakers. The calculation of current in the network elements for different types of fault occurrence in different locations is called as short circuit study or the fault analysis. The result obtained from short circuit study are used to find the relay setting and circuit breaker ratings are essential for power system protection. The selection of circuit breaker for a power system depending not only upon the current of the breaker it is carry under normal operating condition but also upon maximum current it would may have to carry abnormally due to the occurrence of fault. Yes, whenever you provide a circuit breaker, you need to check no the rating current flows through it and the maximum current that flows when the occurrence of fault it needs to be studied so that we are going for this short circuit analysis. In order to approach the problem of calculating the initial current, we need to study the behavior of synchronous generator when it is short circuited. So here the diagram shows the symmetrical short circuit current wave shape. So in this wave shape you can see three region. Region 1, see, wait, I'll show. Can see, this is a sub-transient period, and next one is transient period, and the third one is a steady state period. In steady state period you can see it is going to be constant. So first sub-transient period, the period exists only for the first few cycles of fault occurrence, and the transient period After a subtransient period, transient period exists for a long time, for the next approximately 30 cycles it goes on. So if you compare the subtransient and transient period, the transient period will be much larger compared to subtransient period, because it goes upon up to 30 cycles, whereas that subtransient period it takes for only a few cycles. So then the third region is a steady state period. After transient period, the system is steady state. It's maintained constant. So this period is called as the steady state period. So as I told, the fault can be classified into two: balanced fault and unbalanced fault. And the balanced fault, all three phases are short circuited to each other owing to earth. The voltage and current of system balanced at symmetrical fault occurrence, it is enough to consider any one phase for analysis. So since all the three are symmetrical, if one phase is enough to consider for analysis. So the same thing takes place for the remaining two phases also. Then the short circuit capacity. It is the product of magnitude of pre-fault voltage and the post-fault current. Pre-fault voltage and post-fault current is the product of pre-fault voltage and current, but the voltages need to be taken before the fault and the current of after fault. It is used to determine the dimension of bus bar and interrupting capacity of circuit breaker also. Short circuit capacity, which is equal to V naught IF, and IF is equal to VT by ZT. And short circuit for the single phase is VT square divided by ZT, and for three phases SB three phase by ZT MVA. And the fault current IF is equal to short circuit capacity into 10 to the power 6 divided by root 3 VL into 10 to the power 6. Thank you.